My name's Dan Isla, and I've been here in SoCal for maybe 13 years. So not quite a native, but definitely a transplant like most other SoCal residents. I'm going to share with you a project I've been working on, as well as how I've been continuing to work on it since I left Google. And a little bit of my background, where I'm from, some of the things I've worked on before, and specifically about this open source project I called Selkies, that's used to orchestrate stateful workloads for users on Kubernetes, as well as deliver remote development environments and IDEs to the browser. So since it's a small group here, just curious, how many of you are would say you're developers and you do developer stuff all day, all night? Sweet, definitely all night. Okay, good. What about people do DevOps, maybe systems level stuff, Kubernetes, containers? Yeah, very good. This talk kind of it'll hopefully appeal to both crowds from a developer point of view. I definitely want to share my perspective and some of the tools that I've built around enabling developers to be more productive through remote development environments. And from the DevOps point of view, I'm showing the usefulness of containers, orchestration, and ultimately running a managed service at scale. So we have a whole hour. I have content that fills some of that, but we'll kind of go with it. We can make it interactive. There's a few demos and stuff. So definitely, let's go and jump right into it. I know this is I think it's being recorded and streamed to YouTube. So if anyone out there is watching, welcome to the stream. So again, my name is Dan. I went to Boise State and spent 4 years there studying electrical computer engineering, as well as computer science. And what I learned there over that course of time was basically filing exams are really hard. But in reality, I always wondered why it was so hard to just start programming, right? You have to set everything up. What's all these Java dependencies? What's this left pad thing breaking all my code? And why won't this build on my Mac? It was basically just a lot of hell trying to set up a developer environment so you could just do a simple task. And especially when you're learning in university setting, you're not only trying to learn the language and how to code, but you're also trying to learn what are all these package managers, how does this work, why isn't this working on my machine? And when if you take these practices to your job, then it just continues this cycle of, okay, I got a new computer, this is going to be a problem. Step one, spend a week setting it up, right? So right after Boise State, I moved here and joined the Jet Propulsion Laboratory up in Pasadena. This is where this conference normally is. So it's kind of my stomping ground, and it was for a long time. I was there for about 8 years, and as a systems engineer and tooling engineer. So what I learned there was that operations is pretty hard. And I'm talking about operations, not only software operations and running services at scale, but actual spacecraft operations. JPL, we fly spacecraft to the outer planets and do exploration. Real-time ops is hard. Not only you may have to live on a Mars time schedule, or you're dealing with mission-critical hardware, software, but operations in general is hard. Even in the software world, you're trying to keep services up and running. That might be falling over, and maybe a bug in your code that's breaking not only your services for your users, but at JPL, you're breaking spacecraft on another planet. I did work on the Mars Science Laboratory, or Curiosity rover. It was their landing night. It was a lot of fun. Pretty much the highlight of my career, I guess, at JPL. It was dream job number one, if you will. It was a lot of fun. We landed in 2012. But also what I learned was processes and bureaucracy pretty much ruin all your productivity. As a developer, as soon as a lot of process and a lot of bureaucracy comes into your sprints or what you're trying to get done, it gets really hard to be productive, and it can kind of eat away your soul. So, being productive is very important to developers. We want to get things done, we want to write code, we want to ship it to production. And the more of this that comes into play, the harder that becomes. So we had like a lot of problems. There's things like you have to be given company hardware. You can't code on your own device from anywhere. There's like all this antivirus stuff you have to worry about. There's VPNs. How do I even connect to my source repository? Where is my source repository? What's with the firewall? Work from home was actually really hard at JPL. We didn't really have a lot of tools, such as video conferencing that worked, or streamlined processes to enable work from home. It was very much that office culture. This has changed a lot since 2020, but it's still difficult. It just became a productivity nightmare. So I left to work at Google. So at Google, I joined as a solution architect. Was there for about 4 years, working on cloud, and really wanted to just work for a big company and see what that was like in tech. And Google has always been on my radar. It was amazing, so I joined down in Google Irvine in Southern California here, and was there for about 4 years. And what I learned there was very eye-opening. Right away, of course, the free food was amazing. You basically just, all your meals are provided. It's amazing. Everyone's heard the stories of the Google food, and most of it's true. And also, it was like everything stepping into a time machine and going to the future, and all the technology is completely alien. It's like, what is a virtual machine? I don't know. We have this thing called Borg. All the processes for developing software was very different than something that I'd ever seen before in industry. And it felt very futuristic. Google has this thing they call the Borg, which is literally alien technology, and they were gracious enough to beam down a portion of something that looks like that through Kubernetes to us Earthlings, but they still run Borg for the most part. The developer experience was actually really nice. It was amazing, but it had it was a lot of differences. We weren't allowed to have code on laptops, so nothing from Google 3 was allowed to go to the laptop if you're working from home. Again, you kind of had to be in the office if you wanted to access this stuff, or use some kind of remote desktop. There were no VPNs. This was kind of amazing. Everything just kind of worked. You open your browser, and you can get to your source repository. You can do your code reviews. You just go to a URL, and everything was kind of magic. This was done with like what we now know as like the Beyond Corp proxy and mutual TLS, but it was just kind of it just worked. Code reviews were very straightforward because it was a giant monorepo. You had actual folks that could own portions of that repository. You always knew who to call, who to contact, who to pull into a code review. You had people that were actually certified in readability. Like this person has Java readability, so they're going to automatically be pulled into my code review, and they're going to make sure I'm following all the standards, best practices, and style guides. The monorepo, some of you may have heard Google's monorepo. It works when you're at that scale, and the one thing you have to do is bring in all of your tools. All of your tools have to fit in that model. Like you can't have a distributed repo and have all of your tools kind of working the same way. It's very difficult. So the monorepo, you have to use those tools. They're all built from the ground up. There's very little open source, if you will. And the CI/CDs chains were fully integrated. So everything just kind of worked. You make a change, a small change, everyone gets automatically pulled in to do a review. Unit tests automatically run. Things automatically get deployed out to production. And SRE just kind of holds everything up and running in production. It was very alien, but it was extremely streamlined. The developers were kings, right? They did everything they could to make sure developers were the most productive people in the company. And it was great. So, but this only really works for Google because they started that way. And it's very difficult for an enterprise to kind of shift into that model, especially if you don't need a monorepo, or you don't have all the tooling, or you have kind of a hodgepodge of tooling, some built in-house, some vendored. It can be very difficult. But Google started that way. So the real thing, we're stuck with this little next generation shuttle versus the Borg, trying to figure out how to do Kubernetes good, and while Google's off doing their Borg thing. So what I really learned was that the browser can enable this secure productivity from anywhere. Like I said, any asset we needed at Google, you could just open a browser, go to an internal website. You didn't know if it was internal or external. You could just get to things very easily. Everything, like I said, from code reviews to searching for code, even like writing code in a basic IDE that again was built from the ground up. Only works with internal tools, and also Google Workspace. Most of you probably worked with Gmail or Google Docs or Slides or things like that. It's all in a browser. Like you don't need to install anything. You log in with your normal credentials. If you ever see the login screen, because we have things like SSO that automatically log you into your tools, as well as your source repositories. You've got your little security key that you rub, and that has a browser integration. So everything from two-factor to identity is fully encompassed using browser standards. It also helped that Google owned the browser, right? They own Chrome, and the Chromium open source project, they're the main contributors. So you can actually build a lot of these opinions into your platform or the environment that you want people to be working in. So seeing this, what I really wanted to do was see if we could solve these three problems and bring some of this technology to the rest of the world. While I can't actually take it out of Google, how can we rebuild it so that we can kind of obtain this level of productivity, this level of access, and convenience? So I kind of identified three problems when I was there as a solution architect working with customers, and those were access, access to software, to environments, to tooling, how you deliver that. Do you have to install some client? Do you just go to a web page? Is it in a Google Doc? And then orchestration. How do you run this at scale? How do you deliver it to your entire developer team? How do you enable everyone to be productive day one in a way that is not falling over, in a way that is easy to manage and operate? So from the access point of view, it's my opinion that that remote is actually better. And the thin client is kind of coming back into view. Not only in the Google world, but the browser is your thin client, and the browser can run on almost any device. And so you don't need super powerful local devices. The Chromebook was actually incredibly useful because all you need is a browser, and everything else is being run remotely. This means you have access to better hardware as a developer. You can compile things that are bigger. If you don't have a remote compiler, you are running in the remote environment. So you can have way more memory, CPUs, faster internet connection. If you're working from home and you only have maybe 50, 100 megabits, you connect to a remote system that's got gigabit, 2 gigabit plus network connection. This is nice if you're working with things like Docker. You're pulling in large images and your local connection is crying. No problem. You're just running remotely. Creators running in the remote world become more collaborative. You can build content in a remote session and share it with other peers or collaborators because everyone's connecting in the common point, which really is the cloud at the end of the day. And it lets gamers play from anywhere. You guys may be familiar with Google Stadia. It's a game streaming. There's several game streaming platforms out there now, but this kind of like remote environment, remote connection, remote compute, bringing that all the way to the local device and taking as much off the local devices as we can, is making this remote world that's a little better. And as connections, people are always connected. In fact, internet is like a utility. I think we all learned that in 2020 when we had to go home and work. If your internet goes out, you can't do anything, right? You're very unproductive. So, as the world becomes more and more connected, developers are always online. So the idea of having a remote environment is becoming more and more palatable. I think one of the exceptions is still flying on an airplane, where you have some satellite-connected internet connection. Your remote environment is not going to be so great if you're sitting on a plane, but that's okay. I think I saw a tweet saying maybe you should talk to the person next to you on a plane or take a nap. But either way, remote is coming back, and I think the browser is basically the new thin client. So some of the problems with access are identity authentication. So for example, if you have to download a fat client to connect to a remote environment like an RDP or a VNC client or something, you have to log in twice, or you have to get some special certificate, or you have to somehow integrate with an additional identity system that really just adds friction if you're a developer or really anyone having to deal with multiple layers of authentication. If you're not on the right device with the right configuration that was set up, identity can be a major problem. Networks, firewalls are hard. You know, even running a conference at this scale, you know, there can be network problems. You know, this can be true, especially when you're at home on a home network. You can't rely on someone's router configuration. You're working with your network security team to open firewall rules, make exceptions, you know, peer networks, VPNs, things like that. And then another problem is security and endpoint isolation. How do you isolate your local device from everything else that you might be running on your computer? What if you have a virus on your computer? You know, how are you going to isolate that from your actual corporate IP, the work you're doing, the code you're writing, that environment? How do you keep that safe if you can't trust the local device? Then you get on all these solutions like enterprise for doing endpoint management and virus scanners and trying to stay ahead of the curve. These are problems that come with access. And the web solves the majority of these. For identity, WebSSO has been around for many, many years. You log in with Google, that token follows you around. Any Google asset, it just works. You don't have to think about it. And it's better too, because you can have your two-factor authentication. It's all in the browser. The browser understands these things now, and it's very seamless. Networks and firewalls. You know, the web proxies, things like Nginx and HA proxy are very common now for granting access, integrating with your SSO system, and traversing the network. Also, the browser is pretty limited. You can't really do a whole lot. You can only make web requests, right? You can't just open some random port on some random protocol. The browser just doesn't let you do that. And technologies like WebRTC make this even more seamless. And we'll talk about that a little bit later. From an isolation point of view, this concept of pixel streaming, meaning that the content of your environment never touches your local device. You're just looking at the rendered, you know, manifestation of it and streaming those pixels over the wire. This lets you do things that a lot of CISOs are concerned about with developers, which is like one-way copy-paste. You want to make sure you can copy all your code from Stack Overflow into the environment, but you can't take the custom stuff you write out. So with pixel streaming, you can disable that outbound copy-paste, as well as things like outbound file transfers. And you can also, from a remote solution point of view, you can firewall and control the network environment remotely and make sure you can't like send things to Dropbox or Google Drive or other random things. So that's some of the access problems and the solutions that I've found to them. So let's talk a little bit more about pixel streaming and why this is interesting. So pixel streaming lets you deliver these graphical applications basically as they were built, as they were intended. There's some of these web-based IDEs out there like Cloud9 from Amazon or even Visual Studio Code Server that let you run the IDE in a browser. But at the end of the day, it's not the original IDE, and it may be an IDE you're not really familiar with. And so you're having to do a lot of context switching, like, okay, I used to be able to do this in my VS Code environment or my IntelliJ or my Eclipse environment, but now I'm having to like relearn all this new IDE way of doing things because the environment and the application is different. It's fundamentally different. So by streaming, you can just run that application, send it over the wire, and it's the exact same application that you had on your local device. It's just wrapped in a different way and delivered remotely. Another thing that's nice that I like is that you can recover where you left off. So I like to write some code, maybe run a build or a few builds, step away for a bit, close my computer, maybe go sit on the couch with my laptop, and you open it back up, and you can just resume where you were working without having to switch gears or recover your session or restart a process. If anything, your keyboard is different in the resolution you may have. There's no local dependencies when you're streaming. If you can play a video on YouTube, then you can basically pixel stream to your device. And then, as we talked earlier, the endpoint isolation is another benefit you get with streaming. That adds that extra amount of local device security and isolation. So some of the problems with streaming. The biggest one that everyone throws their hands up at is latency. You know, I mean, there's going to be latency. I'm going to be coding and typing a character, and it's going to take like 10 seconds for it to show up, right? Yeah, that might have been true a few years ago, but it's a little better now. But it is definitely a problem. Bandwidth, you know, you need to make sure you have a good enough internet connection. Image quality, I don't want to be looking at blurry text if I'm staring at text all day trying to write code. It's going to probably give you a headache. And the protocols that let you do text rendering like that and keeping the quality very high. And then, of course, back again, networks and firewalls. How do you create connections that are low latency that can actually get through everyone's crazy messed up networks and also with your corporate networks? It's problems. And there's even more browser-based challenges that are specific to browsers. You know, latency. The browser cannot create direct socket connections. You cannot just open a random UDP port to a server on the internet. The browser won't let you do that. It doesn't know. There's no such thing. And so protocols like UDP that would reduce latency because there's no transmission control, there's no packet queuing, don't exist, right? So the browser has a problem there. You got this TCP congestion control. You can run into this if you're using like WebSockets. You just get this inherent latency because of the protocol you're using and the protocol that the browser is limited to. Then there's image quality and bandwidth. So obviously if you reduce the amount of bandwidth that you're streaming with, your image quality can suffer. And a lot of that is usually related to what codec you're using, the method you're using to compress the image and send it to your browser. And the browser doesn't have all these codecs built in. It doesn't know how to decode lossless images using like a brand new compression algorithm that can give you that nice YUV 444 color correct image. It doesn't have that built in. And so it's something you have to overcome or compromise. And then native interactions. We all know that browsers have these like keyboard shortcuts and things that we're used to doing, Command T to open a new tab, Command W to maybe close one. Well, what if you're like in an IDE and you're trying to use those same shortcuts and now it like closes your whole browser rather than closing the window, the source file you're working with. These are browser problems. The browser likes to hijack some of your shortcuts and developers love shortcuts. So some of the solutions to this. Well, WebRTC fixes a lot of these things. So WebRTC is a standard that recently has been finalized. It's what a lot of video conferencing tools use, and it's for peer-to-peer browser communication. We're going to talk a little bit more about WebRTC here in a minute. But it's basically the only way that browsers can make UDP connections to another endpoint on the internet. So browsers have a WebRTC peer connection object that understands and is very tightly controlled for how to connect to another browser or another server. It doesn't have the latency problems, as many anyway, primarily because it uses UDP and secures it with TLS or DTLS, datagram TLS. So you can get a much lower latency connection. You can. That is much more tolerant to internet traffic and internet weather and problems with packet loss. You can usually recover a lot quicker. And then from an image quality point of view, there's a new standard coming to browsers called Web Codecs that tries to standardize a lot of these more modern codecs like VP9, H.264, 265, and AV1. It's trying to make that more usable within the browser. Right now, the browser supports a lot of those, but it's still not 100% there. And local GPUs. So as of about like 2019 or so, almost every laptop and consumer device has a basic GPU that's capable of hardware decoding these codecs like H.264, VP8, VP9, and that's mainly because of YouTube, because of internet video. In order to decode 1080p video on a low-powered device, you have to have a GPU. Like your CPU is going to cry if it tries to do that by itself. And so they're pretty much standard in every device. You can buy a $100 Chromebook at Best Buy, and it will have a GPU capable of hardware decoding video. And that's really important because if you can't achieve 60 frames per second on your local device from a stream, then your latency is going to be capped, right? Because you're not going to be able to get that sub 20 milliseconds or even sub 50 milliseconds when you add in your network latency. If your computer is trying to decode frames and it's taking hundreds of milliseconds to do so. From a native interactions point of view, progressive web applications, who's heard of PWAs or progressive web apps? Okay, yeah. So these basically give you back the control of your keyboard shortcuts by making the application look like it was installed locally and kind of feel like it too. So you get like the full screen experience, the shortcuts that you would have lost in the browser when it was in a modal view, or you're just like native browser. You get those back. They don't take over the entire system anymore. And it's something you get for free in browsers now. You just have to like write a little manifest, set some JavaScript workers, and you can install your application as a PWA. So these problems mostly were solved with a project called Selkies. So Selkies is the open source component that I started at Google, and for a customer when I was a solution architect, and then open sourced it on GitHub as a way to show people examples of how to solve these streaming problems, how to solve this delivery and access problem in a fairly opinionated way, centered around containers and Kubernetes. So Selkies has a few components, has a broker that's used to actually assign workloads and do identity management, and then it has a streaming component, and this is the WebRTC core that uses GStreamer to encode, accelerate, transport to a browser over WebRTC. So there's a few components of that, but they all run in Docker. They can also be run on a VM, and it's very centered to Linux right now. There's a few efforts in the community right now to port it to Windows, but we're not quite there yet. But yeah, so it's very Linux focused, especially container focused. So I want to show you a little bit about Selkies and talk about this project. So Selkies, like I said, lets you do this kind of stateful workload. So you can basically go to a URL in your browser that's running in your Kubernetes cluster, and it will connect to the WebRTC stream when the container is running. This is the web interface. Connects to the stream, and we're streaming. So this is Rocket League running in the browser using a H.264 with a GPU attached Tesla T4 accelerator. I don't know why the screen is glitching like that. Sorry. Hopefully it's not too disorienting. But yeah, this is streaming at 30 frames per second right now. And there's like pretty much no input latency. I'm sure a pro gamer would be able to tell if there's any latency in this connection. But from a casual, if I was just using this casually, I could play this game and it'd be fine. And this is running at basically 1080p. Yeah, it's streaming to my Chromebook, which doesn't even really have a powerful GPU. It can run videos. This isn't glitching on my screen, by the way. I think it's just their adapter. Let me try to reset it real quick, just so you guys don't go crazy. Come on. Let's refresh. We're going to talk about the WebRTC architecture here in a second. I just want to give you a quick preview. It looks like it's working now. Just a little preview of kind of what it can do and how it works. So like all the my keyboard interactions, my mouse interactions are translated from JavaScript, sent over a WebRTC data channel, and piped into the container. So you get this kind of responsive interactions. And then the video stream is sent over WebRTC. The web interface has some statistics that show up in the side here, giving you an idea of what your current bit rate is, frame rate, latency. The server's running in Oregon right now on Google Cloud. There's like GPU load. gives you some stats around the actual environment, its resolution, as well as the audio. It does have audio. I think it's muted right now. But yeah, so this is the basic web interface. This web interface is very simple. From WebRTC point of view, it's very developer friendly. You don't need a whole lot of code. On the back end point, it's a completely different story. To build a pipeline like this, there's a lot more code on the back end. It's just running on a Kubernetes cluster. And one of the things that you can do with Selkies is GPU sharing. So you can actually run more than one workload on the same GPU. So this Blender instance is running on the same instance with the same GPU in parallel with my Rocket League session. So the other thing, so that's like the GPU accelerated with WebRTC, but you know, Selkies being an orchestration platform can also run things like IDEs and streaming platforms, maybe that don't even use WebRTC. So this is a non-WebRTC application that's running on the same cluster in a container, but this time I'm delivering VS Code into my environment to my browser. So this is the full VS Code IDE. We have access to the entire Microsoft extension library. It kind of looks and feels just like an IDE, but you notice I am still kind of in a browser. So this is that progressive web application where you install it, and it gives you a little icon on your desktop, and it looks just like an IDE you would have locally installed. But now in this view, you know, you have your keyboard shortcuts again. I can do things like Control W, and it closes the tab, and it doesn't look like it's running in a browser anymore. In fact, you can even close it and then launch it from the shortcut, and it will start back up kind of as if it was another application. Okay, wrong application. There it is. There you go. Yeah, again, this is the full IDE, but you know, because we're pixel streaming, this is actually using a different codec. This isn't even using WebRTC. This is using an open source project called Xpra, which basically does window forwarding. So window forwarding is an old Linux concept that's pretty popular on thin clients, actually, where you're only sending the window contents to the remote session, and then it's up to the remote session to style it and put decorations on it and make it draggable. And so that's what Xpra is doing. So this window here, there's basically two windows being streamed in my browser now, and so there's no latency when I'm dragging this window around because it's its own HTML5 element now. So only the window decorations and are local, and the actual contents of the window is remote. But you know, because I'm running a container, in a Linux container in my IDE, I also have access to things like a browser. So I can have an embedded browser that I can run alongside with my IDE that's running on my remote system. So I don't have to worry about firewalls or connectivity if I wanted to test something like a web app. You know, one of the things that developers love is having multi-monitor support. You like to put things in different monitors. How do you do that when you're streaming like a session or a view? So I've built some extensions to the Xpra project that give you this sort of window undock feel that opens up that window in its own thing that you can then drag to any window you want and put them side by side, interact with it. So it gives us kind of this new way of working with Windows in a remote environment. And when I say Windows, I mean like window management. So the Selkies project has several use cases. Some of them are highlighted at the website here. The website's very early. I haven't really put a lot of effort into it right now. But it kind of highlights the main use cases. You know, code editors, one of them, full developer environments with all the tools that you would be familiar with on your local device. You know, doing game development, high performance GPU stuff. This is actually Unreal Editor running in a container on Selkies. This Docker image was 70 gigabytes, 70, to just build and run the entire Unreal Engine. Yeah, it's pretty heavy. And then you can also do game streaming. So we saw that kind of with Rocket League. This is my first prototype, was getting Super Tux Kart running, kind of the hello world of Linux gaming, if you ask me. And so yeah, the website, the main website, and then you've got the GitHub repos for Selkies. This is the broker that we'll talk about here in a bit. And then there's the Selkies GStreamer repo that this is the actual WebRTC component that I mentioned, and we'll dive into a little bit more. So we'll come back to these repos. I'm going to jump back into these slides here. Hopefully the screen isn't glitching anymore. So the theory after building this and proving it out without actually turning it into a product at Google or doing anything like that was just a validation that, hey, if this is good enough for games, then it's probably good enough for developers from a latency, from a productivity, usefulness point of view. And WebRTC is basically at the core of that because of some of the problems identified earlier with not being able to make UDP connections, the codecs, the GPU acceleration. So one of the most popular ways to get a remote desktop in a browser is no VNC. It's an open source solution. And you're basically just wrapping the VNC experience in a WebSocket and putting it into an HTML5 canvas. This is fine. It kind of works if you're just doing like remote system administration, logging into something to check stuff out. If you're trying to do like full resolution, it really starts to suffer. The compression algorithms are not great. It was never designed to run in a browser, so the bandwidth can very quickly shoot to 50, 100, 200 megabits just for full screen video, because they're not using video codecs in VNC. It's a hexile-based encoding with JPEG compression, so it's a very different algorithm that was never designed for the web. So one of the comparisons I built early on was showing a side-by-side difference of what WebRTC and no VNC performance was like. And so this was actually connecting the same container and no VNC running in one process and the WebRTC running in the other process, both accelerated by a GPU and running side by side. So you can kind of see even just the not only pixelization, but just the frame rates are much lower. With no VNC, the best I was able to get was maybe 15, 20 frames per second. And with the full WebRTC hardware accelerated component, we're pushing 60 plus frames per second to the browser out of the same container. And this is mainly due to the GPU acceleration and the protocol that was being used. And for stuff like video, this is fine. You can compress the image quite a bit and not notice like things like artifacts don't bother you that much. No VNC also has or VNC in general, they have like a lossless mode where you can get every single frame or eventually get every single full frame. But yeah, this was like, to me, very eye-opening, like, oh wow, I can now break past that 15, 20 frame per second limit that I had with some of these other open source tools. And I could not find another open source project that would enable this level of performance that wasn't commercial. And so I just decided to build it myself. So that's WebRTC, or sorry, that's no VNC. And so WebRTC is a very different architecture than what you might be used to. Normally there would be like a client-server model for communicating with the browser to a service, and your WebSockets are kind of your only way to do some kind of low latency direct streaming. And usually have a server behind a firewall. You connect to that with a WebSocket from your client, browser that is, and it may have its own firewall that it can maybe get stuff out, but it can't come back in. It's very simple, client-server architecture running over TCP. With WebRTC in a client-server model, you've got a lot more components going on. You've got these things called peers. They're not really client or server, they could be either. And so your peers, if the person running the server is a peer, aka an instance running in the cloud, and the browser being the other peer, they connect together using a signaling server. So a signaling server basically facilitates the call and connects all the peers together and make sure they can have a common place to communicate. This can usually be run over a WebSocket or even just standard HTTP. You're basically just sending little messages saying, hey, I'm here, and the other guy says, hey, I'm here. And they exchange connection details through the signaling server. From a firewall traversal point of view, you have this component called stun and turn. So these are a set of internet protocols used for traversing networks and firewalls. It uses techniques that, I don't know if you want to call like exploit, but takes advantage of some of the properties of how sockets are created and doing firewall hole punching and exposing ports on their way out and making them available for services like WebRTC to get through. So when you have a fully operational stun and turn server, you can traverse just about any network. regardless of what firewall they're on. And so through using stun and this reflexive IP point of view, you can discover ports that are connectable. And if that algorithm doesn't work out, then the turn relay server is used, where you basically both clients, both peers, are connecting, and all traffic is being relayed through a common point. That's the most reliable way to make a WebRTC connection. Can work through pretty much any firewall. And you need this component because, you know, either party could be behind a firewall in a real peer-to-peer, you know, video call or something. And so you need something that can bridge that gap and find that common ground. And those stun and turn candidates are exchanged through the signaling server. So once all that algorithm runs in your browser and on the server side, the peers, the server and the client, communicate directly to each other over UDP and datagram TLS. So you're not going through the signaling server anymore. You may or may not be going through your stun turn infrastructure, but it's a peer-to-peer connection. So the latency is basically as low as your server distance from your client. So because this is kind of a complex system, it can be very difficult to debug. I'm leaving out about 10 of the protocols that are used in WebRTC, but this is kind of like the minimum set of infrastructure that you would need. The unique thing about this client-server architecture for WebRTC is that everything north of the firewall where the server peer is running, you generally have control over, right? You decide where the signaling server runs, and you have control of the firewall that's in front of that, just like deploying any other web service. You have control of where the stun and turn server live. Normally, you don't have that much control in just like a standard peer-to-peer, browser-to-browser. And so because of that, you can expose certain ports and make it feel very much like a standard client-server architecture. GStreamer is an open source video streaming, transcoding, processing engine. It's very powerful. It's very easy to use, and it's been around for a very long time. It's a great platform. It's mostly written in C, but it has some Python bindings that I adopted for Selkies. And you construct these pipelines in a Python application or a C application, and you connect these, what they're called elements, together, and those elements flow from left to right in this diagram. But what Selkies does is takes that X11 application, inputs it to the X11 image source element for GStreamer, and then sends those frames directly to the GPU, where CUDA is used to transform the color space from RGB to YUV 420, which the GPU can actually use. Then it's hardware encoded within the same GPU to H.264, and this compresses the image significantly and creates a new group of images. It's now a completely different protocol than just scraping a bunch of buffers out of your frame, a bunch of frames out of your frame buffer. After it's been encoded, it's sent to the WebRTC bin. This is a GStreamer element that handles all the WebRTC signaling. Or it doesn't only handle signaling. It handles all of the negotiation of the connection, the TLS setup for securing it, and packetizing all of your H.264 frames and sending them over the wire. So that's basically the end of the pipeline. The signaling server that you set up has a web service that runs alongside this. But the Python app in Selkies basically just sets up the pipeline, wires everything together, and then connects to the signaling server. Let's go. Yeah. Selkies was built on Kubernetes, so it has a sidecar architecture by default. I don't know how many of you are familiar with Kubernetes, but this concept of a pod, and a pod may have one or more containers, and the thing they have in common is network and storage. So there's 3 main containers in a Selkies pod. The first one is your actual application. This is like, if you're running Rocket League or you're running your IDE or something, that may be one container. And it doesn't have to have any GStreamer components or dependencies. It doesn't even have to have an X11 server. It just has to have the display variable set correctly, and it'll run. Then you have the actual X11 server that's connected to a GPU. So you can run those hardware accelerated workloads like games, like editors and game editors. And then GStreamer sits alongside in its own sidecar. So GStreamer is pretty big. It has a lot of dependencies. And so the reason why I took the sidecar approach was if you had to require everyone who wanted to stream an application to install GStreamer and have a properly configured X11 server, then every single workload would be different and have to like fight this dependency problem. So the sidecar method cleans that up a bit, and you can run basically any X11 application without modification, just because you land this in the environment and the sidecars are already there taking care of the actual streaming infrastructure. The other thing this allows for is GPU sharing. Not only can the containers share all the GPUs, like the GStreamer app can use the GPU to accelerate the stream, and the X11 server can use it to actually run the workload. But you can also share it with other pods on the node using this method. I didn't mention this, but the GPU, the importance of the GPU is in encoding, and that GStreamer pipeline is what lets you reduce the latency. Not only can your local device decode the stream at a hardware accelerated rate, but you can encode the stream. You know, a lot of times no VNC and VNC or even RDP, they struggle because they can't get the frames and compress them fast enough, right? The CPU is too slow to do that. By offloading that to the GPU, now you can really achieve those higher frame rates because it's clocking out frames in just a few milliseconds rather than trying to crunch on it too long. So you pair those together, remote hardware acceleration encoding and local hardware decoding, and that's how you get those full frame rates. So the third problem is orchestration. How do you actually deliver environments, streaming workloads to the browser in a way that's scalable and easy to manage? So this is where the Selkies broker comes into play. This is there's problems like pod templating. You know, there's tools out there like Helm, Customize, and maybe even just doing some Jinja templating. But how do you create those pods for each individual user in a way that is tailored just for them? There's a life cycle of your pod. You know, when I say launch, when I say shut down, obviously you don't want your end user pod to be running for forever, or it's never going to shut down. It'll cost too much. So the whole life cycle of create, delete, update can be problematic. And then per user routing. So this is a big problem that I found building the solution was, how do I get an individual browser identified user into a single pod on Kubernetes? Normally, when you're running a service on Kubernetes, you put a load balancer in front of it, and traffic is kind of spewed between all the different pods. It's kind of random, or there's algorithms. But the idea of sending it to one pod for one user was pretty foreign. So those are some of the problems that we have. And the Selkies broker seeks to solve a lot of those. And once we have this, once we were able to prove, one, that we can run these workloads in a Docker image, and then two, we can run them on Kubernetes, how do we orchestrate those in a meaningful way? So the Selkies broker creates an abstraction in an operator, and this operator is an abstraction over that custom workload. So you have some manifests written in YAML that are templates. Those are stored in a config map on your cluster. And these are like prescriptive templates for creating those sidecars in that pod architecture, tying together all the GPUs and all the inputs and everything. And then you have the bottom left here, the broker app config. This is that custom resource that is this is my application. It speaks application. It's like, here's a name, a description, an icon, the image that it uses, any input parameters that you want to pass to the templates. And so the broker app config is that abstraction on top of the Kubernetes stuff to make it more familiar to running workloads. Then the controller reads those manifests, reads the custom resource, and owns the outputs, which are a stateful set, which is basically a pod controller, a service, and a virtual service. So virtual services are an Istio component that are basically like virtual load balancers, software load balancers, that run in the Istio proxy, and you can update, you can create these instantly. It's not like reconfiguring a load balancer on a cloud provider where you may add a route or a port, and it'll take like 10, 15, 20 minutes to update the load balancer, because it's like changing a bunch of infrastructure on Amazon or Google. With a virtual service, you can think of that as just like updating like an Nginx config, and then doing a update on the process. So, but this is a now Kubernetes resource, which is a abstraction on top of that language of load balancer. So that virtual service in Selkies world, just like you can do programmable load balancing routes, the virtual service says, hey, anyone with this email address, which is templated by the controller, says if a user comes in with this email address, then send them to this pod, the stateful set. And because the controller owns and knows who the individual users are, because it owns the identity as well, and it knows where all the pods are because it created them, now it can tie together the entire routing and program the Istio control plane to do the routing. So from a templating point of view and lifecycle management, the Selkies operator solves those problems, and then the per user routing was solved by Istio. So those are the major components of the orchestration in Selkies. So at the end of the day, what I learned was basically remote apps in a browser is very enabling. It's liberating from a developer point of view, and just in general being very productive in a remote world. And just like remote apps we showed earlier, IDEs are basically the main one that I wanted to focus on. So after Google, I left about a year and a half ago, to join this company called Utopia. And Utopia specialized in VDI, remote desktop, mostly Windows, orchestrating Windows on Google Cloud. And I saw a fit here where we could maybe productionize the Selkies infrastructure for running developer environments. How can I create this developer utopia at Utopia to solve a lot of these problems that I found? And this really reimagined access to these softwares. No more company hardware. You got to bring your own device. You don't need antivirus stuff because you're running in some container somewhere that gets deleted every time you shut down. You don't need VPNs because you got web-based SSO. You can work from anywhere. It really becomes like a productivity dream. Yeah, so here we go. Yeah, so there's this movement, or I don't know, you can call it a movement, but like DevX, or developer experience, and things we can do to help improve that. I believe that containers are a major part of DevX, and it goes all the way back to this developer environment. Containers allow for consistent development environments. You don't have to, your buddy may have a completely different set of dependencies than you do, and so it only works on his machine. But if everyone's running in the same containerized environment with that was created from the same Docker file, specific for the project you're working on, then all your environments are very consistent. You can pre-install the dependencies and tools that your team uses, and you can basically DevOps your whole environment as code. Everything's a Docker file, put it in your CI/CD, run it, and everyone's got the same environment. You can onboard users much, much quicker because they just authorize them to a platform and they run. So the first productization of Selkies is Utopia Spaces. This is something we launched late last year, which takes the developer use case of Selkies and turns it into a remote development experience for enterprises. So this incorporates all of the security, endpoint isolation, and containerized approach to developer environments. And it's a fully managed service. We run the Kubernetes. You don't have to know how to run Kubernetes. We put an admin portal in front of it, so it's very easy to configure and onboard your developers, and made it very customizable. So this is, again, the first use case of Selkies, and we're looking to do even more, especially on the WebRTC front. So at the end of the day, it's like we want to really meet developers where they are by providing these remote development environments, server-side opinions. And there's this like Devex Stack, if you will, where you have this access layer, which is solved by things like web browsers. And this is where you get portability, data loss protection, SSO. Then you have your environment layer. This is your IDEs, compilers, libraries, and what you get from using this environment is IDE flexibility. You can run any IDE in this environment because it's just sending that window to your browser. You got your tools. You got tools like code reviews, CI/CD, unit testing, and you can increase your reliability, your supply chain integrity just by having everything be very consistent. Everyone's running the same tool chain to verify end-to-end their commits. And then you got your system integration layer, which is your IDE extensions, commit hooks. This is something I'm looking to do next on Spaces, like really tying in the browser at a deeper level into the container so that whenever you commit something, it triggers a bunch of other actions. And this is where you get a lot of that Google-like integration and experience. So no longer does it work on my machine. It actually works on everyone's machine. And that's the end of my talk. Thanks, guys, for hanging out. So we got like maybe 5-ish minutes or so. I'll hang out for a while. We do have a booth down in the expo hall if you wanted to come hang out and chat. Otherwise, I'm here for, yeah, but I'll go ahead and answer a few questions before I shut it down. Yeah. OpenGL, I think that was the question. Can I run all my Steam games on Selkies? You can run some. So Steam has like native Linux games that may use OpenGL or Vulkan, and those work great. Steam also has this compatibility layer, which they added into their Steam Deck. Well, they built it before the Steam Deck, but it's called Proton, which is literally Wine, but for games. Do you guys remember Wine? Wine is not an emulator, yeah, to run Windows applications on Linux, and it's just that, and it works really well, but doesn't have full compatibility. Proton does work on Selkies, an earlier version. I haven't got the latest version to work yet, but it's definitely there. I'm trying to get more involvement on the Selkies repos, so like, collaboration pull requests are definitely welcome. But yeah, you can definitely run many Steam games. I was running Elden Ring a few weeks ago on it, so yeah. Yeah. Mm-hmm. Mm-hmm. Yeah, so I'm somewhat familiar with DCV. I know DCV has a web client, but what I do know is that they have their own protocol. So it's a custom protocol. It's not H.264. It's not JPEG. Things like that. And there's a web client version of it. And it works pretty good. I don't know if it can do the full frame rate like GPU stuff, but it is a custom thing. It's also not open source. And so I was like, I don't even want to touch that, right? For building this and enabling people to use it and making it shareable and collaborative, like it had to be open source. But yeah, it is very similar. I know DCV is what AWS AppStream uses. It's very powerful. It's similar to like I think Terry Dietschy's PC over IP. Yep. So PC over IP is a great protocol. Traditionally, you had to install a client to really get the full performance. PC over IP does support GPUs. And lossless, but you got to have that like downloadable client, which introduces problems with access and orchestration, and it's like, oh my gosh, but it is a great protocol. Yeah. Yeah. Here.
There's really no way to like. So you said you could have multiple windows because it's just progressive web apps, but so if you had multi monitors, right? But like you couldn't like drag a file from this one to that one because it isolated can't.
So drag and drop in a multi-window situation it needs deeper browser integration to do that. So it is possible to do that because the browser does have concepts like drag and drop. You could listen for the drag and drop event and then transport it to the other window or pass the events along. Selkie doesn't do that today. Xpra doesn't really do that today, but it's something that I'm definitely interested in doing. But yeah, right now it really is like, especially with Xpra, it's window forwarding, and so you get like those windows and the events are all there. It's deeply hooked into the X11 libraries. But yeah, that's something that's very interesting. Did you have another question?
When you were looking at the solution for your client, did you look at like Guacamole and just like doing a whole desktop instead of?
Yep, I did. Yeah, there's even some Guacamole stuff in the Selkies code somewhere. But yeah, Guacamole is another protocol. It's very similar to VNC, especially in terms of frame rates. It's a slightly different protocol. It's a text-based protocol, but it has similar encoding mechanisms. But it's not as fast. Like you can't get that. I had trouble getting more than 20 frames per second out. But yeah, it works pretty good. It's a little more browser-friendly because it has like I said, a text-based protocol that's meant to go over a WebSocket. But it was heavy. It was like a lot of it's built in Java, There is a project called Guacamole Lite that speaks to Guac D API directly to your browser and then renders it in a canvas, and that worked actually pretty good. But again, like as soon as you add like a GPU or something to it, it like falls apart. So yeah, not a huge fan of Guacamole for that kind of stuff, but it was pretty good. Plus, like the idea of having a full desktop is kind of, from a developer point of view, I'm really trying to like get people just to realize this is your application, this is the browser, this is the IDE, right? You focus on your code. If you need to like go to a video conference call or chat with someone, just go to a different window. You know, that should be handled on a local device. And you keep your code, you keep your environment. It's just that one app, right? So this idea of app streaming is kind of what I think is the new thin client. Do you have a question back here? Mm-hmm. Oh yeah, so a question about WebRTC versus Quick? Yeah, so great question. So Quick is a protocol that's mostly meant for multiplexing streams, and it's similar to WebRTC. In fact, you can run Quick over WebRTC. So I think Quick is mostly the protocol aspect of it and how you interleave messages and streams and then decode them on the other side. It's an integral component to the peer-to-peer low latency because you can now stream. You have multiplex streams, you only need one connection. And so if that one connection is like a datagram UDP connection, they're going to have extremely low latency and a very, very responsive API. The Stadia team uses Quick for the underlying protocol, and also a newer technology that's going to be using Quick is called Web Transport. Web Transport is a new web protocol that eliminates a lot of the complexity in WebRTC. It takes away the signaling component, takes away the stun and turn stuff, and allows more direct peer-to-peer. That's also, you can run Quick on that, and that's like the future of WebRTC from what I've seen. But yeah. Hey, you go ahead.
Yeah, I just looked through the docs real quick, or the GitHub real quick, and it looks like it's very GKE dependent right now. I don't know if it actually is or just the documentation. Are there any plans to make this a little more platform agnostic?
So wonderful question. Do I want to make this more platform agnostic versus GKE? It's kind of obvious why it's GKE dependent. I built this when I was at Google, and I'm a huge Google Cloud Platform fan. But yeah, so the orchestration layer, the broker, right now, all the Terraform, all the identity stuff is built around GKE. And that's mostly done as here's an example, a best practice that actually works. You can just deploy it right now. I do definitely want to bring it to other platforms. I've started some of that work by bringing the GStreamer component out of the main repo, and now it's its own thing. So I'm starting to work on Helm charts that you can deploy this on any Kubernetes cluster. And the biggest change there is going to be identity and ingress. Like that was a huge problem to solve on Google Cloud. And I was like, in order to solve this for everyone, it's going to be too hard. And so my plan right now is to put it out there. You bring your own ingress, but here's the operator, and here are the containers that you need to run it on any Kubernetes cluster. So trying to finish that out before the end of the year. I have a couple collaborators on that, but it's coming. Yeah, good question. Yep.
I think I misunderstood something earlier about the pixel streaming being able to defeat or handle the endpoint protection.
Mm-hmm.
Thinking from a corporate use case where
Right.
I still imagine you need a trusted endpoint. You wouldn't want to use this like a hotel kiosk in Beijing or something.
Yeah, okay, so I think, yeah, the question was around, do you still need local endpoint protection when you're pixel streaming? So the idea with pixel streaming is that you've isolated your browser from the rest of the device because the text, like there is no content going into your browser other than like the pixels of what you're working with. So if you're working like an ERP system remotely or code, as long as your network is encrypted and you're using your SSO to log in, then you don't have to worry so much about endpoint protection. Now, if you're not on a secure Wi-Fi network and they were doing some kind of like, certificate, man-in-the-middle stuff, then yes, you're still going to have that problem. You will still need to have some kind of endpoint protection for that. But at that point, there's no, almost any solution is going to be vulnerable to things like that.
It's not a Chromebook, it's like a Windows machine.
Mm-hmm.
You run malware on it, right?
Yep.
Pixel streaming is not going to.
So even then, like if you had a bunch of malware on your Windows machine and your browser was open, it'd be like watching a YouTube video right? That malware usually isn't going and attacking YouTube servers, right? It may be like taking your information or doing things, yeah. But yeah, so you still need like some kind of endpoint protection for securing your SSO, the actual login, the identity component of it, and that would be the same for getting to any corporate asset. Yeah, I think the main thing with endpoint isolation is usually centered around a lot of like IP exfiltration and copy-paste redirection. Spaces and the developer use case is great for onboarding remote teams, you know, or like India, even Russia, places where developers and networks aren't as trusted, but you want to just like give them an environment that's sandboxed. They do their work, but they can't like take it out and take your IP with them. Any other questions? Okay. I'll be at the booth rest of the day and a little bit tomorrow. So feel free to stop by. Love to chat more about this project and our product. So thanks again for coming, guys. Appreciate it.